Topic 2.4. We'll be solving these quadratic equations by completing the square. In order to complete the square, we must have the form x squared plus bx plus c equals 0. And we get our new c from from what is b, what is half of b, and what is half of b when it's squared. Alright, so this is in the right form, okay, the x squared plus bx plus c form. Furthermore, we're going to remove the 2 and put it to the other side. So now we have x squared plus 3x, a space, equals negative 2. Now the question is, what is b? B is going to be 3. What is half of b? Half of b will be 3 over 2. What is half of b when it's squared? 3 times 3 is 9, 2 times 2 is 4. So the new number for that gap will be 9/4. So I'm going to add 9/4 to both sides. And we do that because whatever you do to one side, you do to the other. You make sure you balance the equations. This side will now factor into x times x and 3 halves times 3 halves. And the signs will be the same and both positive. In order to add these, we need the same denominator. So right now this has a denominator of 1. We're going to make this negative 8/4 plus 9/4, okay, in order to add these two. Alright, this is going to compress down into x plus 3 halves all squared, and this will combine to become 1/4. Now, still solving for x, we're going to get rid of the square. So we take the square root of both sides, plus or minus the square root. And we end up with x plus 3 halves. And the square root of 1 is 1, the square root of 4 is 2. From there, I'm going to subtract my 3 halves from both sides. And what I'll end up with is 2 equations. One that says x equals negative 3 halves plus 1/2. The other one will be x equals negative 3 halves minus 1/2. Okay. Negative 3 and a positive 1 gives me negative 2/2. Negative 2/2, which ends up being negative 1. On this side, we have a negative 3 and a negative 1, which is negative 4/2. And that simplifies down to a negative 2. Okay. Number 6. Again, we're going to solve this by completing the square. It needs to be in the form of x squared plus bx plus c equals 0. So I'm going to divide everything by 4. This gives us x squared minus 3 halves x minus 3 equals 0. From here, we're going to remove the negative 3, so we have a space here, or the current c, by putting it to the other side. So x squared minus 3 halves x equals 3. Now, to fill in the gap, we're going to ask ourselves, what is b? Then what is half of b? And then what is half of b when you square it? Well, b is negative 3/2. To take half of it, we're going to multiply the numerator by 1 and the denominator by 2, and we get negative 3/4. To square it, we're going to square the negative 3 and get a 9, and the 4 and get a 16. And so 9/16 is what we're going to fill the gap with. So x squared minus 3 halves x equals 3. And we're going to add 9/16 on both sides. This now factors into 2 binomials that are perfect. X and x, and 3/4 times 3/4 for the 9/16. The signs will be the same and they'll be negative. Here, 3 has a denominator of 1, so we multiply that by 16, and we get 48 over 16 plus 9 over 16. Okay, now let's simplify this by writing this as an exponential. So x minus 3/4 raised to the second power. This adds up and gives us 57 all over 16. And now we'll take the square root of both sides. Okay. This gives us, or this simplifies into x minus 3/4. The 57 does not simplify in the root, but the 16 will simplify to 4. Then from here we're going to add 3/4 to both sides, and that'll give us two solutions. X equals 3/4 plus square root of 57 all over 4, and x equals 3/4 minus the square root of 57 all over 4. Next, we're going to solve these, and these are not quadratics, but we're going to see if they're in quadratic form. To see if something's in quadratic form, you take the middle term right here, and we say let the letter u equal that term. Okay, that's how we start off. Let the letter u equal that middle term. Then we're going to square the u, which means we're squaring the term, which is x to the 1/3 times x to the 1/3. You add exponents, we're multiplying x bases, and we get a 2/3 here. Well, this 2/3 matches the original 2/3 here. That means that this is in quadratic form. Since it is in quadratic form, I'm going to make substitutions for these two terms using u squared and u. Now, this is looking like a quadratic formula, or quadratic equation, should I say. And I'm going to solve this using factoring. So u times u for the u squared, 3 times 1 for the 3, and the signs have to be different, so I'll use -3 and +1. This factor, u minus 3 equals 0. This factor, u plus 1 is set equal to 0. And this implies that u is 3, and this implies u is -1. Now, that's solved as a quadratic. We're going to go back and solve it as the original with an x. So this will be x to the 1/3 power equals 3, whereas this will be x to the 1/3 power equals -1. Now we want this to be a single x to the first power. So I'm going to raise this to the 3rd power because powers will multiply. So 3 will multiply times the 1/3 and give us x to the 1st power. So everything gets raised to the 3rd. And that's how we get x, or x to the 1st power. But when you raise 3 to the 3rd power, you get 27. On the next one, we're going to raise this all to the 3rd power as well in order to get this to be x to the 1st power. But when you raise -1 to the 3rd power, you'll get -1. And our answers are 27 and -1 for x. Next, we want to solve this for x, and we want to see if this is in quadratic form. So let's take the middle term here, and we're going to let the letter u equal the square root of x. Then let's see what is x squared. U squared, shall I say, u squared. Well, if you square the square root of x, the square root goes away and you get x. Well, this x matches the original term here. Therefore, what we have here is a quadratic form. So I'm going to make this look like a quadratic by making substitutions of u. So this will be u squared equals minus 4u minus 5 equals 0. Now I'm going to solve it as a quadratic. U times u, and 5 times 1 for 5. The signs will be different, so let's put -5 and +1. U minus 5 set equals 0, and u plus 1 set equals 0. implies that u is 5 and u is -1. Okay, that was solving the quadratic form. Now let's go back to the original form that uses x's. So u will be represented by the square root of x equals 5, and this will be the square root of x equals -1. Now, with this one right here, there is no number that you can take the square root of and get a negative answer. There is no number that you can take the square root of and get a negative answer. So this we wouldn't work with in the first place because the answer would be false if we were to try to get an answer. Again, no square root of a number produces a negative answer. For this one, we're going to remove, this is a positive, so this is okay. We're going to remove the square by squaring both sides. The square here removes the root, giving us just x, and the square turns 5 into a 25. And that's our one solution there.